I'm Anil Kumar, sharing with you a very important question on applications of quadratic functions. A ball thrown vertically upwards with an initial velocity of v meters per second falls on the ground due to the gravity g. The height h in meters of the ball after t seconds is given by the relation h of t equals to minus half gt square plus vt. Show that the ball will reach maximum height v square by 2g. I showed maximum height of v square by 2g at t equals to v over g. That's the question for you. You must have seen this question with numerical values so many times. So here is a general solution for this particular question. So we are given h of t, the height of the ball at any instance of time t, is equals to minus half gt square, minus because ball is thrown upwards and this gravitational pull is downwards, so that makes this minus. T is time in seconds, acceleration is meters per second square, plus velocity with which the ball is thrown, initial velocity, right, times t. Okay, so that is the equation which you always see. Value of g is 9.8. So let me just remind you here. G is equals to 9.8 meters per second square. So at times you will see a minus 4.9, which is exactly half of this, or round to half of 10, which is minus 5 in the equations which are related to projectile motion of throwing things which come down. Okay, everything comes down anyway. So I hope that reminds you of how we get this equation, and also the questions which you have worked on, similar kind of questions where you will see a minus 4.9 something something, right? So those are based on this particular equation. So if we have a solution to this equation, then we can solve all those equations. That's the whole idea. So it is a general solution to any projectile motion quadratic equation. We need to find the maximum height and the time when it is reached, and the method is complete the squares. Perfect, right? So the method is complete squares. That is how we can find the maximum of a quadratic function, right? So parabola is opening downwards, so it will have a maximum, correct? So the steps involved, as you know, are, so we'll take minus half common, and we're left with the coefficient g, right? Minus half with the coefficient g. So we are left with t square, minus taken outside, so it is minus, right, to make it positive when you multiply, and then you multiply by 2 over g, right? So we get 2 over g v t. So that is what you get, right? Now to complete the squares, we have to make half of this term and then multiply by the coefficient, right? Plus and minus, and square it and add it and subtract it like this. Minus g over 2 t square minus 2 over g vt. Half of this term means, let me show you which term, 2vg, this term, right? The coefficient of t, half of this term. So half of this term is, we have to add and subtract that square. So 2 will cancel, we get v over g, right? We get v over g whole square minus v over g whole square. This is called completing the squares, correct? So you add and subtract one value. Because you are adding and subtracting same value, you're not changing the equation. But a useful change happens that these three terms become perfect square. So we could now write this as minus g by 2 or half g t minus this term v over g whole square, and this term is left. Let's multiply, square it. We'll multiply with this term later, v square over g square. Is it okay? And now if you expand it, you get this is written as minus half g times t minus v over g whole square. And you multiply this by that term, it becomes plus half g times v square over g square. Correct? Now let me rewrite this equation right there. So we have this equation as h of t equals to minus half, now this term g t minus v by g whole square plus half, g and g cancels, so we get v square by g, v square by g. So knowing this, we know this is a parabola whose vertex is at v over g, this term, right? This is the t value, the independent value, right? And the y value, which is the maximum, is v square by 2g. This negative indicates that the parabola opens downwards, and therefore we have maximum. Do you see that? So from here we can conclude that the maximum height is equals to that, the y value, in this case the height h of t, which is v square by 2g, and it occurs at time t equals to v over g, right? This time v over g, the independent value v over g. Now this is a very, very important conclusion from this particular video, and it can really help you to answer especially the multiple choice questions very fast. So you don't really have to do all this completing the squares for such equations, which will be there for you many times, and you can conclude that the maximum height really occurs at square the velocity divided by twice acceleration. The time at that time will be the quotient of velocity and acceleration. Correct? I'm Anil Kumar, and I hope that helps. If you like, you can like it. You can always share and subscribe. Thank you, and all the best.